Hi everyone, this is 𝐑𝐤𝐿𝐴 from Edureka. In today's session, we're going to discuss about the two most popular DevOps tools, which is Jenkins and Docker. And we are going to see how these tools can be integrated to achieve a better software delivery workflow. So first off, let me run you through today's agenda. First, we're going to see what exactly Jenkins is and how it works. Next, we're going to see how Docker solves the problem of inconsistent environment by containerizing the application. Once we're done with that, we'll briefly have a discussion on microservices because on the hands-on part, I'm going to deploy a microservice-based application by using Jenkins and Docker. Now, after you've got a brief idea about microservices, we're going to look at a use case and see how to solve a problem statement by using Jenkins and Docker. And finally, we're going to move on to the hands-on part where we'll deploy a microservice-based application by using Docker and Jenkins. So guys, I hope you find the session interesting and informative. Let's get started with our first topic. Now, before listing down a few features of Jenkins, let me tell you some fun facts about Jenkins. Currently, there are over 24,000 companies which use Jenkins. To name a few, there is Google, Tesla, Facebook, and Netflix. Now, there has to be a reason why such reputed and successful companies make use of Jenkins. Now, let's discuss a few key features and see why Jenkins is so important. All right. Now, the first feature is that it is an open source, freely available tool, which is very easy to use. It has various features like the build pipeline plugin, which lets you graphically visualize the output. And apart from that, there is also a feature known as user input, which lets you interact with Jenkins. All right. Now, one major feature of Jenkins is that it implements continuous integration. Now, what is continuous integration? Every time a developer commits into a source control management, that commit is continuously pulled, built, and tested using Jenkins. Now, how does Jenkins do all of this? Now, Jenkins has over 2,000 plugins which allow it to integrate with other tools like Docker, Git, Selenium, etc. So by integrating with other tools, it makes sure that the software development process is fully automated. All right. So it is also an automation server which makes sure that the software delivery cycle is fully automated. Now let's see how Jenkins works. So here you can see there is a group of developers committing their code into the source code repository. Now every time a developer makes a commit, it is stored in the source code repository. Now what Jenkins does is every time a commit is made into the source code repository, Jenkins will pull that commit, build it, test it, and deploy it by using plugins and other tools. All right. Now, not only is it used for continuous integration, it can also be used for continuous delivery and continuous deployment with the help of plugins. So by integrating with other tools, the application can be deployed to a testing environment where user acceptance tests and load testing is performed to check if the application is production ready. And this process is basically continuous delivery. Now, it can also make use of plugins to continuously deploy the applications to a live server. So here we saw how Jenkins can be used for continuous integration, continuous delivery, and continuous deployment by integrating with other tools. All right. Now let's move on to what is Docker. Now, before we discuss about Docker, let's compare virtualization and containerization. Now, the goal of virtualization and containerization is to solve the problem of the code works on my machine, but it does not work on the production. Now, this problem happens because somewhere along the line, you might be on a different operating system. Now, let's say your machine is a Windows machine and you're pushing the code to a Linux server. Now, this will usually result in an error because the Windows and Linux support different libraries and packages. And that's why your code works on the development server and not on the production server. All right. Now, when it comes to virtualization, every application is run on a virtual machine. Now, a virtual machine will basically let you import a guest operating system on top of your host operating system. Now, this way you can run different applications on the same machine. All right. Now, you're wondering what is the problem with virtualization? Now, one major drawback of virtualization is that running multiple virtual machines on the same host operating system will degrade the performance of the system. Now, this is because the guest operating system running on top of your host operating system will have its own set of kernel and set of libraries and dependencies, which take up a lot of resources like the hard disk, processor, and RAM. And another drawback is that it takes time to boot up, which is very critical when it comes to a real-time application. All right. Now, to get rid of these drawbacks, containerization was introduced. Now, in containerization, there is no guest operating system. So instead, the application will utilize the host operating system itself. So basically, every container is going to share the host operating system, and each container will have its own application and application specific libraries and packages. All right. So within a container, there's going to be an application and the application specific dependencies. I hope this is clear, guys. Now that we've discussed containerization, let's see how Docker uses containerization. Now, Docker is basically a containerization platform which runs applications within different Docker containers. So over here, you can see that there is a host operating system on top of which there is a Docker engine. Now, this Docker engine will basically run container number 1 and container number 2. Now, within these two containers are different applications along with their dependencies. All right. So basically, within a container, every application is going to have its own dependencies installed. So it does not have to bother any other container. Okay. So basically, there is process level isolation that happens here. All right. Now, there are three important terminologies to remember when it comes to Docker. Now, the first is the Docker file. Now, the Docker file basically contains the code which defines the application dependencies and requirements. All right. And through the Docker file, you're going to produce the Docker image which contains all the dependencies, such as the libraries and the packages of the application. Next is the Docker container. Now, every time a Docker image is executed, it runs as a Docker container. So basically, Docker container is a runtime instance of a Docker image. So now let's look at a Docker use case. Now over here, you can see that I've created a Docker file. Now within the Docker file, I basically defined the dependencies of the application. Now out of this Docker file, a Docker image is created. So basically the libraries and the packages that the application needs is installed within the Docker image. Now every time the Docker image is run, it runs as a Docker container. Now these Docker images are pushed into a repository known as Docker Hub. Now this repository is very similar to the Git repository, wherein you are committing code into the Git repository. In this case, you're going to commit Docker images into the Docker Hub repository. All right. Now you can either have a private or public repository depending on your requirements. Now after the image is published to Docker Hub, the production team or the testing team can pull the Docker images on their respective servers and then build as many containers as they want. All right. Now this ensures that a consistent environment is used throughout the software development cycle. Now let's look at what are microservices. Now guys, I'm going to explain what microservices is because we need to deploy a microservice based application in our demo. Just to take it up a notch, I've implemented microservices. Now first, let's look at the monolithic architecture. Now over here, let me explain this with a small example. Now on the screen, you can see that there is an online shopping application which has three services: customer service, product service, and cart service. Now these services are defined within the application as a single instance. So when I say single instance, it means that these three servers will share the same resources and databases, which make them dependent on each other. Now, if they share resources, obviously they're dependent on each other, right? Now, you must be wondering what's wrong in this architecture. Now, let's say that the product service stops working because of some problem. Now, because the services are dependent on each other, the customer and the cart service will also stop functioning. So basically, if one service goes down, the entire application is going to go down. All right. Now, when it comes to a microservice application, the structure of the application is defined in such a way that it forms a collection of smaller services or microservices, and each service has its own database and resources. All right. So basically, customer microservice, product microservice, and cart microservice will have their own database and their own resources. And therefore, they're not going to be dependent on each other. All right. So they are basically independent, autonomous microservices. All right. Now let's look at a few advantages of microservices. Now, the first advantage is independent development. Now, when it comes to a monolithic application, developing the application takes time because each feature has to be built one after the other. So in the case of the online shopping example, only after developing the customer service, the product service can be started. So if the customer service takes 2 weeks to build, then you have to wait until customer service is completed, and only then you can start building the product service. All right. But when it comes to a microservice architecture, each service is developed independently. And so you can develop customer service, cart service, and product service parallelly, which will save up a lot of time. All right. Now, the next advantage is independent deployment. Now, similar to independent development, each service in a microservice application can be deployed irrespective of whether the service before it was deployed. So each service can basically deploy individually. Now fault isolation. Now when it comes to monolithic application, if one of the services stopped working, then the entire application will shut down. But when it comes to a microservice architecture, the services are isolated from each other. So in case any one service shuts down, there will be no effect on any other service. Now the next advantage is mixed technology stack. Now each microservice can be developed on different technology. Now for example, the customer service can be built on Java and the product service can be built on Python and so on. All right. So basically you're allowed to use mixed technology to build your microservices. Now next is granular scaling. Now granular scaling means that every service within an application can be scaled independently. So basically the services are not dependent on each other. They can be developed, deployed at any point of time, irrespective of whether the previous service is being deployed or not. So guys, I hope you're clear with the advantages. Now over here, we're going to compare how microservices can be deployed by using virtual machines and Docker containers. All right. Now when it comes to a virtual machine, now let's say that we have a microservice application which has 5 services. Now in order to deploy these 5 services on a virtual machine, we'll need 5 virtual machines. All right. Now each virtual machine will be for one microservice. Now for example, if I allocate 2 GB RAM for each virtual machine, then 5 of these virtual machines will take up 10 GB RAM. And the microservices may not even require so much of resources. So we'll just end up wasting these resources, and at the same time you're occupying too much disk space, which will degrade the system's performance. Now let's see how Docker containers deploy microservices. So instead of running 5 virtual machines, we can just run 5 Docker containers on one virtual machine. Now by doing this, we're saving up a lot of resources, but when it comes to a Docker container, you don't have to pre-allocate any RAM. The Docker container will just utilize the resources that are needed. And another point to remember here is that Docker containers are lightweighted. They do not require additional guest operating system. Instead, they just share the host operating system. All right, so this makes them very lightweight when compared to a virtual machine. Now let's move on to the use case. Now basically we're going to try and understand the problem with the help of an analogy. Now over here you can see that in the favorable environment, the soil is fertile and the tree is watered at a regular basis. And as a result of this, the tree grows properly. But when the tree grows in an unfit environment where the required dependencies for growing a tree are not present, then the tree will die. All right. Now similarly, when an application runs on an inconsistent environment which does not support the application dependencies, then the application will fail. All right, guys, now let's look at the problem statement with a small example. Now let's say that a developer is building an application using LAMP stack. Now after the application is developed, it is sent for testing. Now this application runs properly on the testing server, but when it is deployed to production, a feature or the entire application fails. Now this may happen because the Apache version of the LAMP stack is outdated on the production server. So due to the difference in the software versions on the production and development server, the application fails. Now in order to get rid of the inconsistent environment problem, we're going to deploy an application using Docker. Now Docker will make sure that the environment throughout the development cycle is consistent. Now deploying a monolithic application can cause many problems. Like for example, if one of the features of the application stops working, then the entire application will shut down. So for this reason, we're going to create a microservice based application and build it on the Jenkins server and finally use Docker to maintain a consistent environment throughout the cycle. So over here, you can see that there are 4 microservices, and for each microservices, I've built a Docker file. All right. So first, let me discuss what each of these microservices do. Now the account service and the customer service are the main microservices, whereas the discovery and gateway services are supporting microservices. Now account service will basically hold the account details of a customer, and similarly the customer service will have a list of customer details. Now discovery service, which is a supporting service, will hold details of the services that are running on the application. And apart from that, it will also register every service in the application. Now what the gateway service does is, on receiving a client request, it will route the client request to the destination service. Now to be more specific, it will provide the IP address of the destination service. Okay. So now that you know how these microservices work, let's move on to the next part. Now basically these microservices are coded and their dependencies are put into a Docker file. Now for each of these Docker files, a Docker image is created by packing the Docker image with the jar files. Now how do you create a jar file? A jar file is created by running the mvn clean install command, which basically cleans up anything that was created by the previous builds, and it will run the pom.xml file, which will download the needed dependencies. So whatever dependencies are needed are stored in this jar file. Alright. Now once the Docker file is packaged with the jar file, then a Docker image is created for each of these microservices. So here we are going to use Jenkins to automate all of these processes. So Jenkins is basically automatically going to build and then push these Docker images to Docker Hub. Now after the images are pushed to Docker Hub, the quality assurance or the production team can pull these images and build as many containers out of it. Alright. So basically over here, we're going to create Docker files for each of these microservices, and then we're going to package these Docker files along with the jar files and create a Docker image for each of these microservices. Alright. Now after creating the Docker images, we're going to push these images to Docker Hub, after which the quality assurance or a production team will pull these Docker images onto their respective servers and build as many containers as they want. I hope this is clear. So now let's practically implement all of this. Alright guys, so I've logged into Jenkins and I've created 4 different jobs, each for one microservice. Alright. Now let me just show you the configuration of one of these jobs. Now let's go to account service. Let's go to configure. So guys, make sure that you enter your GitHub repository here. So go to source code management, click on Git and then enter your repository URL over here. Now let me just show you what we're doing here. Now within the build step, I've selected execute shell. Now let me just show you how that's done. So it's simple, just go to add build step and click on execute shell. So when you click on execute shell, a command prompt will open like this and you can type this code on that. Now what I'm doing here is first I'm changing the directory to account services because I'm running the account service within this job. After that, I'm performing an mvn clean install, which I explained earlier. Now once we're done with that, we're going to build a Docker image and then we're going to push it to your Docker Hub account. Now these are the credentials to my Docker Hub account, where Zulekha is the username of my Docker Hub account and Edureka-demo is a repository that I've created in my Docker Hub account. Then click on apply and save. Now apart from account services, I've built jobs for the other services as well. Now let me just show you customer service also. Let's go to configure. Now within the source code management, like I said earlier, enter your repository URL. After that, go to the build steps. Over here, you can see that I'm changing the directory to customer service. Then I'll perform mvn clean install. So next I'm going to build Docker images. Now over here, customer is basically the tag of the image. So whenever this image is going to get pushed to my Docker Hub, the tag is going to be customer. Alright. Now similarly for account service, the tag was account. Now I've done the same thing for all the other jobs. Alright. Click on apply and save. Now guys, in order to run these 4 jobs as one workflow, I've created a build pipeline. Now this pipeline will basically execute these 4 jobs in one workflow. Now if you want to know how to create a build pipeline, please refer the video in my description box. I'm going to leave a link where you can see how to create a build pipeline. Alright. Now let me just show you my GitHub account. Now over here you can see that I have account service, customer service, discovery service, gateway service, and also there's Zipkin service. Now guys, this service basically keeps a track of all the other services. So it's going to keep a track of where the requests are going and how the requests are getting sent from account service to customer service. Now within account service, you can see that I have a Docker file, Jenkins file, and a pom.xml file. Alright guys, now let's start building our application. Just click on run. Now here you can see that account service is getting executed. Now let's individually go to account service first. Let's click on account service. Alright, here you can see that it's building this job. So basically here what we're going to do is we're going to change the directory to account service. After that, we're going to perform an mvn clean install and then we're going to build an image and push that image to Docker Hub. Alright. So guys, remember to provide your Docker Hub credentials. Now this job has successfully executed. Now after this job has executed, it's going to trigger the next job, which is customer service. Now let's look at the build pipeline. Now over here, this has turned green because account service has completed execution. Now customer service is currently running. So let's look at the build in customer service. So after the account service has completed execution, Guys, you can also check the output of account service from here. Scroll down, it says success. Now, after account service has finished, let's trigger the customer service. So customer service starts executing now. Now let's individually look at customer service. Now over here, you can see that customer service is building. Now in this job, we're basically going to change the directory to customer service. After that, we're going to perform an mv and clean install command. And then we're going to build and push a Docker image to Docker Hub. All right. So once this is completed, the next job in the pipeline will get executed. Okay. All right, guys. So this is successfully executed. Now you can see that customer service has also turned green, which means that it has successfully finished building. All right. All right, guys. So you can see that customer service has completed execution. Now let's trigger the build of discovery service. Now let's look at the output of discovery service. So guys, you can see the output from here itself. Let's click on console. All right. So within the discovery service again, we're going to change the directory to discovery service. After that, we're going to perform an mv and clean install. And once we're done with that, we're going to build an image and then we're going to push it to Docker Hub. Guys, make sure you have entered your Docker Hub credentials. All right, guys, so this is completed execution. You can see that it says success. Now it's triggering the new build, which is gateway service. So here you can see that gateway service has started execution. Let's look at the console output. All right, so similarly in gateway service, first you're going to change the directory to gateway service. After that, you're going to perform an mv and clean install command. And once you're done with that, you're going to build an image and then push it to Docker Hub. So guys, gateway service has successfully completed execution. Now the build pipeline has fully turned green, which means that the entire workflow has completed execution. Now let's go to our Docker Hub account and see if all these images got pushed to Docker Hub. All right. So I'm going to my Docker Hub. Now let's go to the Edureka demo repository. Now over here, you can see that the account, customer, discovery, and gateway services, all of these 4 images are pushed to Docker Hub. All right. So with this, we've come to the end of the demo. Now, after pushing these images to Docker Hub, any quality assurance team or any testing team can pull these images onto their respective servers so they can easily deploy this to production. So guys, I hope you understood the demo. If you have any doubts or any queries regarding today's session, please leave them in the comment box. All right. So guys, thank you for joining me in today's session. Have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!